Hello team, today's challenge is lowercase words, where we're given a string of different words and we need to return only the words that are all lowercase. If they have any sort of uppercase letters, like good is all uppercase, not has the capital N, the capital T, then we skip those words. So there are a couple ways that I can think of to do this. I'm sure that there are plenty more, but right off the bat, we could split just like this, creating a regular expression. It's going to be global. I'm going to set any sort of white space. They guarantee a space. So if you just wanted to replace all of this with a single space, you can. But I have been in print for long enough that double spaces are a real thing. And I want to be able to capture those just in case. You never know when someone's going to hit the space bar twice, right? Or an accidental tab or something like that. So that captures all the white space as much as there is. We're splitting on all of it, and then we are doing stuff. So filter, we're going to filter the word, and the word is going to be word equals word dot to lowercase. Now, if you lowercase a lowercase word, it's already lowercase, right? So in that case, this word would be equal to this word, which means that it's a pass and it returns. If they don't match, then it means that something inside of there was uppercase and it skips it. It filters it out, okay? At which point the only step left is to join. And we join on an empty string just like this, and it works, right? Works quite simply. It's pretty performant at around 700,000 ops per second, so not a problem, right? Another thing that we could do is we could use regular expressions, right? Just kind of like we did with the space up here. We can set up a regular expression. It's going to be equal to something that is global. What are we looking for? Well, we're looking for any word character, okay? This is going to be a weird one. Any word character, just like that. That's kind of weird. 0 or more, right? And then inside of here, we're looking for anything that is A to Z, capitalized. It must be A to Z, and there must be at least one, right? So it's saying it can right here, this part, it could start with a capital letter, or it could end with a capital letter, or that capital letter could be somewhere in the middle. We don't care how many capital letters there are because that will be captured by /W, but there must be at least one capital letter, right? At which point, because of the nature of our string, I also want to get rid of the extra space, right? So right here, I'm going to capture an extra space. And again, as much white space as there is, right? In case there's more than one space. Now with this, we're always getting the space at the end, which means how do we capture a word that is at the end? In this case, they don't seem to have an example of that. But what if lowercase had a capital C for whatever silly reason, right? Well, in order to do that, we need to capture the end, because right now we're capturing, as an example, all with a space, but there is no space after lowercase, so we need to do something there. And we do that with a or $, just like this, to say the end of the string, okay? At which point we should be able to use that. So return that string again, and we're going to replace, just like this. What are we replacing? Well, it's the regular expression with nothing. Okay, and this still works. It works quite well. It's pretty efficient. We can actually make this slightly faster, I found out while I was doing some research afterwards, where if you add a word boundary, right? A word boundary is a /B. We can put one here. We could also put one here. A word boundary is kind of an invisible character that separates space from words, right? It doesn't always work out. There's more nuance to it than that because of things like punctuation. But for us, the way that this sets up, we basically say, I want a transition. That's what the border is, right? A transition from something space-like to a word. And on the other side, I want a transition to space as well, right? This still works. It doesn't change anything, but it speeds things up like hotcakes, okay? So if we jump over here, you'll see that I've done a bunch of regular expression tests, okay? And one of those is this one isn't really a regular expression unless you count the split, right? But we We split, that's the first one. And then I tried it with a callback. Callback was strangely half the speed. Very simple regular expression in there, not too fancy, right? Anything that wasn't a white space character matched with anything that is a space character. So simplifying. And then, of course, our word boundary. So right here, we have that. And in fact, I didn't include it on the other side on this, but we could do that. So if I run this, you'll see this this jump around, and it should be, 1,370,000, right? If I remove that, I think it is slightly faster, right? Where it was 1,400,000, a little less, right? It's acting up. I did get this up as over 1,400,000. Apparently, it's not going to do that on screen. But if I remove that boundary, right? So this should be the exact same thing as this right here. No word boundary. Then it is small. Like it's so slow, right? And I can run this again. We're going to see it. The exact same regular expression, only no word boundaries, right? And it is almost a third of the size because of that word boundary. There's something about word boundaries that is being optimized inside of JavaScript. So I'm not convinced that you should use it all the time, but if you find that your regular expression is slow, you might try adding one, right? To see if it optimizes the regular expression behind the scenes, okay? So that's it. If we jump back here, then we can review, right? We started off, again, not every solution, just hopefully 2 good solutions. That's what we did today. So we started off by splitting. We filtered all the words that were not uppercase, or that were not lowercase, sorry. And then we joined it back up on a space and sent it out the door because that's what they expect. Down here, we set up a regular expression where we said any number of any kind of characters, right, 0 or more, with at least 1 uppercase and 0 or more following that. And then, of course, the space or the end of the line, right, just to make sure that we cover it all. And if we match that, then we empty it out. We just get rid of it completely. And then, of course, talking about word boundaries a little bit, because that helps to optimize it somehow. Again, still learning. I feel pretty comfortable with regular expressions, but I don't use word boundaries that much. So I need to do some research too. Which one did you like? Did you go a different way? Did you find another solution that you'd like to share? Hit me up in the comments with all that good stuff. Otherwise, today this has been Lowercase Words, and I will see you tomorrow.